So in the last video, we talked about functions of one real variable, and we reviewed the idea of the derivative of a function of one real variable. Now, the other day, I was sitting with my wife in a room, and we had this AC running, and I was feeling cold. I asked her, like, are you feeling cold too? And she said, no, I'm feeling hot. So that was surprising to me. But we were sitting in the same room, the air conditioner was on, but she was feeling hot, and I was feeling cold. What was going on there? So if I think of temperature as a field, as a function, which I have to define in a room, temperature now would be a function of more than one variable. So it could depend upon where I'm sitting in the room versus where my wife was sitting in the room. And in general, for a room, the temperature can depend on three variables: the x coordinate, the y coordinate, and the z coordinate. Now, let's say you were to tell somebody, how much does the temperature change if I move from one point in the room to the other point in the room? And this is the essence of how we define derivatives for functions of more than one variable. So let's see how we can do that. Let's think of the temperature as a function of three variables: x, y, and z. And let me make an attempt at drawing a three-dimensional room. So let's say this is the x-axis, that's the y-axis, and this is the z-axis. And here we have the temperature at the point x, y, z. Now let's suppose I move from the point x, y, z to a neighboring point like this, which is denoted by x plus dx, y plus dy, z plus dz. And if I were to ask you the question, how would you write down the change in the value of the temperature as I move from point x, y, z to the neighboring point x plus dx, y plus dy, and z plus dz? How do you think you'll do that? Why don't you pause the video for a moment and then come back and see if we agree with our answers? So hopefully you've given it some thought. The way I would try to describe the change in the value of the temperature would be dt is equal to t, which is defined at the point x, dx, y plus dy, z plus dz, minus the temperature at the point x, y, z. That's fairly simple, right? We just take the value of the temperature at x, y, z. We take the value of the temperature, or we measure the value of the temperature at x plus dx, y plus dy, z plus dz, and we just take the difference of the two. So that's how we will measure the change in the value of the temperature. Now, how do I introduce the idea of a derivative in this sort of complicated looking function? Well, one of the things that we can do is we can appeal to the definition of a derivative, which we are familiar with for functions of one variable, and try to see if we can apply that definition here. So I'm not going to fill in the steps right now, but I'm going to leave this as an assignment for you to do. And then once you have given it some thought, in the next part of the video, I'm going to show you how we can actually do that using derivatives. Thanks for watching. See you soon.